Good morning, class 8. Let us start the next chapter. This is chapter 4, Work, Energy and Power. In your previous class, you have already studied work and energy. In this chapter, we will extend it to power also. So, just recall what you have studied about work. Do you remember what is work? Work is said to be done when we apply a force on an object and the object is moved in the direction of the force. Okay, so the movement is important and in the direction of the force, right? Suppose this is a pen, I am pushing it, it should move in the direction of force. Now if I apply a very small force, it is not moving with that force. Okay, so even if I am applying force, I am not doing any work because I am not able to move it in the direction of the force, right? And what is the formula for work done? Work done is equal to force multiplied by the displacement. Okay, the distance through which the body is moving, that is d. Okay, so force multiplied by the distance. So what will be the conditions for work to be done? First thing, the point of application must be displaced. Okay, so first thing, let me write it for you. First thing, the point of application of force, the point of application of force must be displaced. Okay, and second thing, the displacement should be in the direction of the force. Okay, displacement should be in direction of force, right? So these are the two conditions for work to be done. So when is work said to be done? When the point of first condition, when the point of application of force is displaced, and the second condition, the displacement should be in the direction of force, right? Point of application of force means, suppose this is an object and I am pushing it from this side, I am applying the force. So this is the point at which I am applying the force, right? So this is the point of application of force. And when will we say that no work is done? When there is no displacement and if the displacement is at right angles to the direction of force. Understood? The displacement is at the right angles to the direction of force. So these are the two conditions. We will discuss it in a while. So first let us discuss the unit of work. This you have already studied, that unit of work is joule. Okay, and how do you define joule? Let us say you know the formula of work done, right? You already know the formula of work done. So work done is equal to force multiplied by the distance. Suppose force applied is 1 Newton and displacement when we apply 1 Newton of force is 1 meter, then what will be the value of W? 1 multiplied by 1, that will give us 1 joule. Okay, so how do you define joule? 1 joule can be defined as the work done when 1 Newton of force displaces a body through 1 meter, right? And in the direction of the force, you have to keep in mind this. Keep in mind always that you always have to say that in the direction of force. So how do you define 1 joule? When 1 Newton of force displaces an object through 1 meter, इतना हो गया. Now in the direction of force, in the direction of force, whatever direction I am applying the force, the body should move in that direction only, right? Then we say that this particular force is doing that work, right? So you can see here 1 joule of work is done when a force of 1 Newton moves the point of application of force through 1 meter in the direction of force, right? So this we had to understand the 2 points that we just said, that no work is done if there is no displacement. See these examples they have shown you. See figure A. First let us see figure A. Now see this object, 2 forces are acting on this object. First is this one, its weight that will be acting downwards, right, towards the earth, and the second one will be this force that the man is applying on it. Okay, this is the force P. So when the man is applying this force P on this object, what is happening? This object has displaced from this point to this point, right? So the displacement here is in the direction of the force, right? So here we will say that this man has done some work, right? But see the second case, B part, this man is pushing a wall, okay? So whatever force he is applying, you need a lot of force to push the wall, but will the wall move? No. So because it is not moving, no displacement is occurring in the wall, that is why whatever force he may apply, he is not doing any work, right? So the first condition was the displacement should be there. If there is no displacement, no work done. Here there was displacement in the direction of force, we said work is done. Here there is no displacement, that means no work is done. Now the displacement should be in the direction of the force. Now see here, this man, he has taken some weight on his head, okay? So what is he doing? See the weight of the box that will be acting downwards, so he has to put a force equal to the weight of this box to hold that on his head, right? So even if he is holding this box, he is applying force, but is the box moving? No, the box is only kept on his head. The box is not moving, right? So no displacement, no work done. Now suppose this man takes this box on his head and he is walking. Now when he is walking, what will happen? See the point of application of force is D over here, right? This is the point of application of force. So when the man is walking, suppose he came here, so the point of application of force has been shifted from this point to this point, okay? Though the point of application of force has displaced, but has it displaced in the direction of the force? No, because the direction of the force was upward, right? The direction of the force was upward, and he is moving in this direction, right? So the displacement was at right angles to the force applied. The force applied was in this direction and displacement was in this direction. So these two things, the displacement and the force applied, were perpendicular to each other, were at right angles to each other. This is the condition for no work to be done. So even if the man is carrying this weight and moving, still he is not doing any work with that force, right? He might be walking, he might be putting so much of energy, so much of force he must be applying to carry this box, but because the force applied and the displacement is perpendicular to each other, we will say that no work has been done. So the conditions for no work done, the no displacement, or the displacement and force applied, the displacement in the direction of force applied are perpendicular to each other, right? And what is the condition for work to be done? The point of application of force must be displaced. Okay, there should be some displacement, and the displacement should be in the direction of the force applied. You have to open your mind and just keep absorbing all this and keep thinking, right? So this is all the same thing they have explained. You just go through this, and these are the two examples, numerical examples. So we'll do it now, and you also just practice in the way I will tell you, right? So in this way you will be practicing the numericals also. So let's see. See, I have written this numerical over here.